Hi, I'm Ed Zynda, and this is What the Funk. So in this video, we're going to demonstrate how to accept funds into a contract from other Ethereum addresses. And to demonstrate that, we're going to create a contract that lets users buy concert tickets. So let's say, for example, we want to put on a concert. We'll put on a funk concert to be exact. And we're going to allow people to send money to the contract to purchase a ticket, and then their address from which they send their Ether from will be registered as somebody who owns a ticket. And then we will take a set number of tickets and reduce that number of tickets every time somebody buys tickets until we have no more tickets. And at the end of that, we will go ahead and return all of the funds for the purchased tickets to the creator of the contract, which would be us. So let's dive in. So you can see I've already created this funkconcert.sol and an empty contract called funkconcert. So we're going to need a few things. First thing we're going to need is the owner's address. So that would be our address. The next thing we're going to need is tickets to hold our number of tickets. So that's going to be an unsigned integer for tickets. And then we're going to need a price for the tickets. So we're going to use a constant. So this will be an unsigned integer constant, and we're going to call it price. And a constant is just a variable that you can't ever change once it's initialized. So because this is the case, you have to initialize it with a value as soon as you declare it. So we're going to give it a value of 1 Ether. So let me stop and explain this a little bit. Solidity allows you to use these different modifiers to represent value in your contracts. So every contract on the blockchain works in the smallest possible denomination of Ether, and that would be the way, spelled W-I-E. And one way is actually 1/quintillionth of an Ether. So it's like one with, I don't know, a lot of zeros. So I could either type like a whole bunch of zeros like that to represent the price, or I could even do 1 times 10 to the 18th, like that. But it makes more sense to just use the actual unit. So in this case, I want one ticket to cost 1 Ether. I know today's price, that's probably around $200, $350, but just for simplicity's sake, we're going to stick with 1 Ether. This is a very expensive concert. Next, we want to create a registry for whoever bought tickets and how many tickets they own. So for this, we're going to use what is called a mapping. And all a mapping is if you're familiar with the PHP language or other languages with associative arrays, it's just a variable that stores keys and a corresponding value. So in this case, we're going to create a mapping that uses an Ethereum address as the key, and that is going to point to a value, an unsigned integer, and that's going to be the number of tickets that our purchaser bought. So we're going to call that purchasers. And we're also going to make this public so we can actually check to see who's actually purchased and how many tickets they've purchased. So after that, we're going to need to initialize a few things. So to do that, let's create a constructor. And in the constructor, we'll set the owner to message.sender. Remember, message.sender in the constructor refers to the address creating the contract or deploying the contract. And then we're going to set the number of tickets. We'll set it to 5 because I'm going to show you a few things later, and I don't want to purchase a ton of tickets just to show you how that works. So this is going to be a really exclusive, expensive concert. The next thing we're going to do is create a function to where we can actually purchase these tickets. So we're going to call this buy tickets. And when we buy a ticket, we're going to be able to specify an amount of tickets. And to make sure that this function is able to receive Ether, we need to make it payable. And payable is just a keyword. So you just add that to the end of your function. It seems I have an error. Oh, not sure why there's an error. Oh, okay. So unused local variable. Yeah, this will complain if you create a variable and don't use it. So when we have someone purchase a ticket, we want them to specify the number of tickets. We also want them to send a valid amount of Ether. So the first thing we want to check for is if they sent the right amount of Ether for the amount of tickets that they want to buy. So if the message.value, that's message.value corresponds to how much Ether they sent to this function. If it's not equal to the amount they want to buy times price, then we want to throw an error, throw an exception. But one other thing we want to check for is whether or not we have enough tickets left. So we're going to add this or clause. So or the amount they're trying to purchase is greater than the tickets. So if they haven't sent enough money or they're trying to purchase too many tickets, we throw an exception and we quit. Otherwise, we'll go ahead and set a key on the purchaser's mapping to denote that this address bought however many tickets. Now, mappings in Solidity don't actually have an undefined value like maybe you would see in JavaScript. So if the key doesn't actually exist yet, you can actually reference the key and it will just give you 0. So we don't really need to do anything to initialize a key. All we have to do is know that by referencing the index of the sender's address, that it's going to be 0 to start off with. And so we can just add the number of tickets that they actually bought. So we'll take the message.sender, which is the address of whoever is trying to buy the ticket, and then we'll just add the number of tickets that they successfully bought. So plus equals amount. Then we'll go ahead and remove that number of tickets from the total number of tickets that we have. So tickets minus equals amount. And that should be it. So we'll go ahead and create this. Because we made this public. Actually, let's go ahead and make this tickets public as well, just so we can see how many tickets are left. So we'll go ahead and create this again. And so Solidity and Ethereum automatically create getters for any sort of public variables. So this tickets getter is automatically created, and we can already see that there are 5 tickets left in this contract. So let's go ahead and select an address from down here, and let's go ahead and try and buy a ticket. Buy 1 ticket. Now that fails, and the reason that failed is because we didn't actually send any ether. So let's go ahead and send 1 ether, because that's the price of 1 ticket. And let's go ahead and buy a ticket. And as you can see, that was actually successful. So let's clear that out. And we can actually check the number of tickets. Oh, so here's another thing to note. If you're working with this Remix IDE and you're trying to run a function that's not payable, if you try and send money to it or ether to it, it's going to fail. So if you're trying to work with a non-payable function, go ahead and clear out that value box. So we'll go ahead and run tickets again. And as you can see, there are only 4 tickets left. We can also copy this address and take a look at the purchasers at this index. So the index would be the address of whoever just purchased the tickets. Click that, and you can see we have 1 ticket. We can try and buy 2 more tickets. We're 2 ether, 2. Buy the tickets. The transaction went through. We'll make sure we clear that value. Check how many tickets are left. 2 tickets are left. Let's check how many tickets we have total. And we have 3 total. So let's see what happens if we try and buy a ticket with the wrong price. So let's give 1.5 ether for 1 ticket. Boom, it fails. So this makes sure you're only buying or sending the correct amount of money for however amount of tickets you want to buy, no more, no less. Let's actually try and buy, so there's 2 tickets left. Let's try and buy 3 more tickets. We'll give the right amount of money. I'll close out all these. Buy 3 more tickets, try and buy the tickets, and boom, we can't buy more tickets because there are only 2 tickets left. We're trying to buy 3. So if we buy 2, successful. See how many tickets? We got to clear that out again. 0 tickets. So what do we do now? Basically, your contract is stuck. You can't do anything else with it because all the tickets are bought. They've already been sent to this address. What else can you do with it? So here is one cool trick you can do with your contract. There is a method called SelfDestruct. And basically what SelfDestruct does is it will totally remove the contract from the blockchain, and it also takes a parameter, and that parameter is an address. So when it removes the contract from the blockchain, it will send the current balance of that contract to the address that you passed through the parameter. So we are going to self-destruct this this contract. So after allowing someone to purchase a ticket and removing the tickets from the total amount of tickets, we're going to do a check. If tickets equals 0, self-destruct. And we're going to send everything back to the owner. So basically what we're saying is once all the tickets are purchased, once everybody has their tickets, we destroy the contract and send all the funds back to us. So we're going to go ahead and create that. Get rid of that. And so let's note our amount of Ether in this address. So it's 4.99999 whatever. We're going to buy 5 tickets at 5 Ether and buy all the tickets. Now, well, that was a bad example because it was 4.999. Anyway, we got all that money back. So you can see we just got 5 more Ether deposited back into our account. If it was a bigger balance, we would have seen a difference in 5 after the account was closed. So just, I guess, believe me that the contract was destroyed and the balance was actually sent back to our address. One more quick trick I'm going to show you is to use something called a fallback function. So Solidity allows you to create one function within your contract that has no name whatsoever. And this function, called a fallback function, is called if you're trying to call a function by a name that doesn't match anything else in the contract. So one useful scenario for this is for allowing people to send money from their wallet directly to the address of the contract. And because just sending Ether to the wallet, because sending Ether directly to the wallet actually doesn't call a function by name, it'll hit this callback function. And the way you allow Ether to be sent straight to the contract is to use the Payable keyword just like you would with a normal function. So this fallback function is Payable, and we're going to allow people to send money straight to our contract to buy a ticket. And because fallback functions can't take an argument, we're only allow them to buy 1 ticket. So we're just going to call buy ticket from within this function, and we're just going to buy 1. And not sure why this works. Buy tickets. So we're going to buy tickets, buy 1 ticket, and we're going to do that just by sending Ether to this. Oh, also another thing to note, if you're trying to create a contract, this value has to be empty as well, because creating a contract is another transaction and sending money to create a contract is not allowed. So we'll create that. It's created, and you can see we have this fallback function. So we're going to utilize this fallback function, or click on this fallback function, and it's going to represent us actually sending money straight from our wallet to the contract. So go ahead and click the fallback function. Invalid opcode. We've got to send Ether. I keep forgetting this. So send Ether, click the fallback function. It's successful. Let's copy our address. We'll check the number of tickets. Once again, get rid of the Ether. Check the tickets. 4 tickets left. Check to see how many tickets we actually own. And we have 1 ticket. And that's it. So in this video, we covered payable functions, self-destructing your contract and sending the funds back to the initial creator. We've talked about using mappings and constants. I hope you enjoyed this video. If you like it, please click like. If you like the rest of my content, please click subscribe and check out some of my other videos. And I hope to see you in the next video.